These are the solutions to the first practice quiz for quiz 6 of quadratic linear systems. So you just want to look at the first 3 problems here. You look at the graphs and that determines the number of solutions, 0 and 1. Right there. There will be one of each. Pretty simple. Okay, solve each using graphing and tables. So I do want you to use graphing and tables on this, and the work is coming on the next page. So we will do this. So x squared plus 2x plus 4, and then x minus 5. So you're looking for, where your y values are the same. And you can take a peek at the graph too. And guess what? We do not have points of intersection, so you would not see any of the y values coincide. And now you just want a graph. Okay, so 1, 2, 3, 4, 5, we can do a couple of points for this is where you would go to the table now. First thing is the quadratic, the second one. So 0, -5 is a point that I used, and then 5, 0, whatever points you want to use for the line. But when you do the quadratic, you must get the vertex point, and then just a couple of other symmetric points when you do this. So there's the line, and then the vertex for the quadratic is at -1, 3. So you see that pattern again above and below. And just pick a couple points, let's say 1, 7. I like just going, a couple of ones away from the vertex. That gives me a little bit of room to do the graph. But you're doing that every time. So you always have a graph. Even if there is not a solution, you always have a graph. So number 5, I'm going to pick the pace up here. This will be where the solution lies, -2, 3. So you have a horizontal line, y equals 3. That means it goes, all the coordinates have a y value of 3. So there's that. And then the vertex of this happens to be at -1, 3 of that top one. And then a couple other points I chose 0, 7. And then use symmetry to get the other one. So what I mean by symmetry is that you went 2 to the right here to get that one, so you line up on the vertex and go to the left to get that one. So at -1, 3, you would see that if you put them both in, which you should do, and then 3, you would see that at -1 or -2, oops, x squared plus 4x plus 7, whoops, I messed that up bad, just 3. You would see that at -2, there we go, 3, you would see the same y. So that always has to happen when you do this. On this one, you're going to see it at -2, 9, and 1, 3. Okay, so again, you go and I want you to use the table on these. They're going to show up on the table. Do they always show up on the table? The answer is no. But you search around. They're going to be pretty easy to find. I want you to be aware of that pattern so you can immediately put these in. So there's the 2 for the line. And then the quadratic will also go through those. But you need the vertex point of the quadratic, which is 0, 1. See that above and below 0, 1 there? And then you'll have a couple others. And so just go 2 more this way. What's called using the axis of symmetry to get your other point. So I went 2 left that way, then I just go 2 right that way to get the other one. So there's your 2 points. All right, second page. So you want to solve these, and I'm looking for your new quadratic. When you do this, so you're setting them equal to each other, and I need the new quadratic. So plus x equals 0. Subtract x, subtract 1. When you solve this, you're going to get 0 and negative 1. And when you solve it and get the solutions, you should write them like that. You can put them up here, but you really need to start them out in a coordinate, because we're looking for a coordinates where this is true. So 0 plus 1 and then negative 1 plus 1. So those are the solutions. I did something mean to you on this next one. The solutions are not nice. So x squared plus 6x plus 4. I need to see the new quadratic. I need to see this. That's what I'm going to be looking for, that you knew that much in your work. So you get negative 5.2 about, and you get negative 0.8 about. So you start off a coordinate, and then you need to substitute those into the y equals, the second one, and figure out a y value. So this one gives you 11.4 and 2.6. So this one ended up not being nice. I think on the quiz I'm going to make them all nice. So this one will be an empty set. So plus 2x plus 9. And when you run that through, there will be no real solution to that. You can expect one of each there. So here is the same idea. You're going to take these two, and the x's are the how many days in where there's the same number of people at the pool, and then y is going to be the number of people. And it can be no solution, 1 or 2. Make sure you understand that. But you do the same process that we have done. So subtract 28x over, so that's 11x plus 60. If you get a negative, you're done. You can't, so if any of them are negative, I meant to say, so negative 1, 11, and 60. So you see that negative 4 is no good. So 15 is the only one. And then how many, you have to take that back in. So 28 times 15 plus 4. And that is 424 people. So after 15 days, there's 424 people. So that's a one solution problem. There's going to be, the rest of them that you do might be two solutions. That's just we had to throw the one solution out because it's in the negatives. There's no such thing as a negative number of days. So here we go. This will be the toughest spiral. And I put it on an easy quiz so that you'll probably get the quiz part done pretty quick so that you have time to do this. So 0, 9, this is going to open down. Just make sure A is negative 1, B is 0, C is 9 when you do this. But take a look at the graph to make sure that you're doing this right. So we have a maximum value at y equals 9. Remember, you take the y value of the vertex to put into that. The y value of the vertex is what's needed. And no max. Max. My bad. Maximum at 9. No minimum. Axis symmetry, that's the x value of the vertex. X-intercepts, you're going to be able to find these on your table. That's where y equals 0. Y-intercept is when x equals 0. Get them from your table. This is what we did when we did all that quadratic formula, by the way. Okay, so please understand that that's, when I say x-intercepts, when we completed the square, we did the quadratic formula when you use polysimul 2 or when you get them from your table. Domain is all reals, so you're going to probably want that initial set of notes. The very first quiz is set of notes. When we come back to this range, so remember me talking about the box. You get the top side of the box in here, meaning that the right-hand side of the range is a 9. So this is the bottom and top of the box. This is the left and right side. Well, we don't have a bottom or a left or a right side because this keeps getting wider and wider and keeps going down and down. So it only has a top to it. So these are the 4 sides of a box that you try to put around the graph. This will always work for domain and range. It's a very simplistic way, but it's the idea. And you'll get more complicated functions that you have to think about, but it works for almost all of your graphs. So if you can't get any sides of the box in, then it's infinities everywhere. That's a line. A line has infinities, all reals. By the way, that's what this means, all reals. All right, so intervals of increasing and decreasing. This is where you put and you come over here, so you split it down the x value of the vertex, and this is less than that and greater than that. And then what you do is you trace the graph left to right. So here I'm rising, and on the other side I'm falling. And then my 2 ends of the graph are going down forever. Okay, so second graph, I'm going to go quick, so follow along. I see -2, -3 as the vertex, and this is opening up. We have x-intercepts that are not nice, but 0, 1 right here. Okay, so we have a minimum value at -3. Remember, that's the y value at -3. That's the y value of the vertex, and that occurs in that. So that goes either here or here, depending. Axis symmetry, it's the x value of the vertex. X-intercepts, they are not nice. You're going to have to run this through polysimul 2. Oh, well, okay. I see. A little tricky. I'm not being nice to you on this. So you have to square this out. So x squared plus 2x plus 2x plus 4x plus 4 minus 3. You have to run x squared plus 4x plus 1 through. I'll do that on this one, but I will not on the next one. And then it will generate those for you. You got to expand it out. That's when y equals 0. It will not be on the table. The y-intercept will always be on the table. Domain is all reals as usual. Range, we have the bottom side of the box, so that's through -3. By the way, this is always the y value of the vertex. The vertex determines a whole lot of stuff. So x is less than -2, x is greater than -2. So you input the x value of the vertex. So decreasing, increasing. And end behavior is positive infinity as you keep increasing there. Okay, so that is the first practice quiz for quiz 6.